thank you for that very nice and very flattering introduction. I want to talk today not so much about current events, or I'm not actually going to fulfill Andrew's agenda there, but I do want to talk kind of a big think piece, or a piece that's much more about some of the larger trends that I think are going on and what their implications are. I kind of like to take a historical perspective on this, and to tie this into information rules. When we wrote the book, we talked about what we thought common economic forces were behind a number of technological revolutions, and we needed examples, and it was very easy to go to history to pull out those examples. And I'll tell you, one really good thing about using history is you know how it turns out. So this business about economics 2001, it's a little risky forecasting in 1998 what economics 2001 is like, but if you go back a few hundred years, it makes life a lot easier. So some of the examples I want to draw on here are historical examples, but my hope is they have some parallels today. As someone once said, history may not repeat itself, but it rhymes. And maybe we can pull out a few of those rhymes. Let's see, I have to make the technology work.
Is it working?
I don't think so.
I don't think it is. You try
There we go. All right.
an old mouse.
Like this? There we go. Okay. So the general theme is something called computer-mediated transactions, and I'll tell you what I mean by that in a few minutes. But I want to start out, well, here's a little outline, I guess. I'm going to talk about waves of innovation and their implications, and I want to introduce the idea of combinatorial innovation, so I'll talk about that for a few minutes. And then I'll move into this computer-mediated transactions, which are the main theme for the talk. And at the end, that will move naturally into some discussion of collaborative computing. So let's start with the waves of innovation. So we've seen this big innovation in the last 15 years. We've got the web pages, the search engines, the wikis, the databases, the Twitters. I mean, everything else has been rolling on us. Each few months, there's been another kind of innovation. Why so much, and why so quickly? I think that's a question we want to ask. Where did all this innovation come from? Why has it happened so fast? And I think of it as an example of something you might call combinatorial innovation, because every now and then you get a set of component parts, and there's a wave of innovation or burst of innovation as people combine and recombine these component parts to create new inventions. So in 1800, it was interchangeable parts. That's kind of an interesting story there. Thomas Jefferson came to France, and he saw that the French gun makers were so skilled that they could actually build weapons where you could interchange the parts. So this simplified logistics dramatically. And when he came back to the United States, he said, we must be able to master this technology. Now, the trouble was, of course, Europe had all the master technicians, and the US had a bunch of rejects who couldn't get a job in Europe, so they had to emigrate. And what happened was they had to build a technology which allowed them to create these interchangeable parts. And it was that technology of building the gears and the pulleys and the wheels and the shafts and all those mechanical innovation that went on that allowed the 19th century to be such a hugely innovative period as people combined those parts to create the sewing machine and the washing machine, and towards the end, the bicycle and the automobile. And of course, in 1900, you saw this wave of innovation set off with the gasoline engine, where you were able to create the automobile. Think of the Wright brothers. What did the Wright brothers do? They took bicycle technology, kite technology, and the gasoline engine and created this brand new innovation, the airplane. And that was really combinatorial, working through the innovations. And of course, in many of these cases, you see a lot of parallel invention because people are working with the same basic components, and to a large extent, it's a matter of chance who gets there first. Edison maybe was the first person to create the incandescent light bulb. He has a pretty good claim. But the reason he was first is he had the best vacuum pump in the United States, which actually came from Germany. And in many ways, Edison's biggest invention was the invention of the research laboratory, where you had all of the component parts, both the physical parts and the knowledge parts, to create these innovations in that context. In the 1960s, we saw integrated circuits, which are a wonderful example of combinatorial innovation created for just a few special uses. They became a multi-purpose technology, which then has found its way into almost every device that we use on a daily basis. And in 1995, I picked the date somewhat arbitrarily, but around 1995, we saw the internet, which again provided a set of component technologies which set off this huge wave of innovation. Now, the interchangeable parts took 100 years because you really didn't truly get interchangeable parts until Henry Ford. If you go look at the 1911 Encyclopedia Britannica, Henry Ford wrote the entry on mass production, and he said, "There is no fitting in mass production." What he meant was, in those days, you had a part, you had a file, and a lot of the mechanical work was filing the part down to fit in the device you were trying to assemble. Well, obviously, that couldn't work on an assembly line, and so you couldn't have the assembly line, at least in the modern form, until you were able to create interchangeable parts that really worked. And as I say, that took 100 years. Integrated circuits took probably decades. Gasoline engine, I don't know, 30, 40 years. But the internet, we've seen just in this last 15 or 20 years, we saw a huge range of innovation. Why is that? Well, my claim is that the component parts this time, if I can get the internet to work here, there we go. Component parts are all bits. That's an amazing thing. We've got TCP/IP and HTTP and CGI and SQL, and all of these component parts are bits. You don't run out of them. You don't run out of HTML. Just like you don't run out of email. There's no time to delay, there's no shipment, there's no logistics. These protocols, these specifications, these programs can be shipped around the world in seconds, and you can have innovators working through this combinatorial process to find the products that really work, the products that really create a demand that people find appealing. And we've seen the web pages and the intranets, the chat rooms, auctions, exchanges, video streaming, tweets, I mean, everything else that's happened in this last decade or 15 years. So we get this extremely rapid evolution in technological progress, in part because we're no longer working with mechanical parts or electrical parts or physical parts at all. It's really just working with these standards, protocols, languages, and basically bits. So the question is, what are the implications for commerce? So if you start with this vision of combinatorial innovation, then I want to bring this to the question of what does it mean in terms of economics or commercial activity. So, obvious point, a computer is involved in almost every economic transaction. So there's a buyer, there's a seller, but then there's something in the middle, that's a computer. And so that's why I refer to computer-mediated transactions. Now sometimes that's very mundane, there's just a cash register. But if you look at virtually all cash registers these days, it's really a PC with a special interface. Special interface has the keyboard maybe and the screen that displays the transaction. And if you go look at a web-based transaction or a business-to-business transaction, there's a database that's sitting between every buyer and sellers. And the original intent in putting the computer in the middle of the transaction was pretty mundane. It was just to do the accounting, right? Just to keep track of each of the transactions. But that record of transactions, once it's created, it actually has a number of very interesting uses. So the theme for the next 15 minutes or so is how does the presence of these computer-mediated transactions affect economic activity? Now, I said I wanted to give a little historical pitch to this because this is really the culmination, or at least the culmination so far, I suppose, of a process that's been going on for thousands of years of how technology, in particular record-keeping technology, has helped develop commerce. So I want to give you a few examples of this. Let's see, did I go the right direction? Oh yes, this is the outline for computer-mediated transactions. These are the 5 themes I'm going to discuss, that having these computer-mediated transactions in addition to just the accounting side allows you to enforce new contracts, better align incentives, makes data available for extraction and analysis, enables controlled experimentation, and enables personalization and customization. So I'm going to talk about each of those in the next few minutes. But back to the history. I guess I'm not quite at the history yet. Well, I'll talk about the, yeah, there we go. Now I've got to go the other direction here. Yeah, back. Let's see. Previous. One more. I'm giving away my talk here. All right, so now let's look at this first result. The idea that once you have this computer-mediated contracts, or you have better technology for recording and observing transactions, you can write better contracts. Now you think about a contract, that's really fundamental to commerce. I'll do X if you do Y. That's the basis of virtually every economic transaction. Goods, services, labor, whatever. But the problem is you've got to actually monitor the contract. Because when I say I'll do X, you'll do Y, well, you have to verify that I've actually done X before you really perform your part of the contract. Now, sometimes in a simple exchange, it's very easy to observe the performance. But in other cases, maybe the quality of the good or the service or the transaction isn't easily observable. The effort may not be observed, for example, and so it may be much more difficult to actually enforce the contract that's made. So where do computers come in? Well, typically you see these advances in technology that enable better measurement and monitoring, and therefore they've ended up enabling better and more efficient contracts. So that's the first theme. And nice example, here's an accountant. Here's a famous accountant. I bet you didn't even know there was such a thing as a famous accountant. But this guy is Francesco Di Marco Dattini, also known as the Merchant of Prato. He invented the letter of credit, which is be a nice thing to put in your resume, I guess. Since a computer serves as this intermediary, it can not only record the transactions, but also, in some sense, verify the contractual performance. And that allows you to structure more elaborate contracts and thereby improve economic efficiency. So part of the reason I like this picture is you think, what would Dattini do if he really had a computer? He could do much more exciting accounting than he was able to in his own time. So let me give you a few examples of this. I'll start back at the beginning, about 5,000 years ago, with an example for Mediterranean shipping, and then come up to development of office equipment in the late 1880s, trucking, video stores, and online advertising. I don't actually mean to imply that online advertising is the peak of all commercial transactions and performance, but it's just a nice place to end up in this the particular discussion. All right, so Mediterranean shipping. I love this example. How do you ensure that your shipment is received at the other end of the voyage when you have no written language? So it's an illiterate and innumerate society. So what they did was, I thought, ingenious. You had little clay tokens, they're called bullae. They were in the shape of whatever was being shipped. So if you're shipping olive oil, you had a little token that looked like a barrel of olive oil. The tokens were sealed in a clay envelope when the ship was at the harbor where the material was loaded. So the harbor master, every time a barrel of olive oil went on the ship, the harbor master moved the token from one side of his desk to the other. No counting necessary, just doing a one-to-one correspondence. After all the barrels were loaded, they sealed up the clay, they stamped the official seal, baked it in the oven, handed it to the captain. The captain goes to the destination port. The clay envelope is taken out, it's cracked open. Every time a barrel comes off the ship, they move a token from one side of the desk to the other, and at the end, the tokens better match. Okay? And that was the accounting. It was an amazing mechanism for a society that was as primitive as that particular society. And later on, they marked things on the outside of the clay envelope to indicate what was inside, kind of a double entry bookkeeping, if you will. And many people think that's what's actually led to written language. So it's a beautiful example of how you could allow these commercial transactions to take place at a distance, to have the equivalent of a bill of lading or to have the equivalent of an accounting mechanism with actually completely enumerate society. So let's see, I have a nice picture here. If you look, these are examples of bullae from 5,000 years ago Each one corresponds to one of the different items that was shipped during that period. And in fact, they still find these whenever there was a shipwreck. Of course, the bulleye went down with the ship, and it's fairly common to find these in the Mediterranean even today. All right, next example. As businesses get bigger, and as soon as you expand outside the family, you have a problem. You have these strangers working for you. And how do you ensure that they're actually performing what they should perform and not stealing from you? Well, one nice solution to this problem was the incorruptible cashier, which is a wonderful name. It's the name of a patent issued to James Ritty and John Birch in 1883. There's a picture of the incorruptible cashier. How did it work? Well, I had two innovations. One innovation is whenever the cash drawer opens, a bell rings. Ka-ching. So then the owner knows to pay attention because he knows the drawer's open. That's why cash registers make a noise when they're opened up. And the second thing it had in it was a primitive computer. It had a paper tape, and the paper tape marked every transaction. So you had a complete record of transactions. At the end of the day, you could run through them. You can compare the amount that was in the drawer to the amount that was taken out, and that allows you to reconcile the purchases and cash disbursements, the cash that came in, the cash that came out, and it allows you to have more effective monitoring of employees and allowed businesses to scale. Allowed businesses to get much larger than they were before because they didn't have to be limited to just a small trusted set of users, since you had a way of monitoring even people who weren't necessarily trusted. And if you look at trucks, it's kind of interesting. Go out to the highway, and every truck that you see going down the highway now pretty much has a computer in it, a vehicular monitoring system. And again, these were put in place for logistic reasons, to be able to route the trucks to wherever they should be. Many of them have satellite monitors, so their routing can change in process. But you had a kind of nice side benefit that it improved mileage quite dramatically, and improved mileage by eliminating a certain kind of fraud, because it was fairly common for a trucker to go to his friend, put gasoline in his friend's truck, charge it to the company credit card, and then take a side payment from the friend. Well, all of that disappeared as soon as you could monitor the performance of these contracts, very much like the incorruptible cashier was now the incorruptible gas tank. Video store rentals. This is a beautiful example that came from the late 1980s. Many people in this audience are old enough to remember the bad old days of the video store. The bad old days when the video was so popular you could never find it, right? So it was so popular no one was able to rent it. And the reason was they had an inefficient contract, because a video store owner would go out and purchase the video for a fairly high price, bring it back to the store, and then rent it out as many times as possible so he could recoup his investment in purchasing the video. So the price was quite high. It was $50 for a video back in the mid-'80s. So they only bought a few, and because they only bought a few, most of the people who wanted the video were inevitably disappointed. But then they said, let's move to a different contractual form. And the contractual form was a revenue sharing model. So there, the distributor gave the video to the store. It wasn't a purchase, he gave it to it. But every time the video was rented, the distributor got a cut of the revenue. So the video rents, let's say, for $5, the distributor gets $2, the store gets $3. Everybody's happy. The distributor now wants to give as many videos as possible. The owner wants to have as many in stock as possible. The customer always finds the video. It's a win-win-win all the way around. Made the industry phenomenally more efficient. But you have to be able to count the transactions, right? If you can't count the transactions, there's no way to verify the performance. And the technology to count the transactions was the barcode scanner and the network computer. And it wasn't anything as fancy as the internet in those days. It was just a dial-up modem that called up the central office and said, this is how many copies of this video were rented out today, this is how much money we got, here's your revenue share. So again, it was simply being able to monitor those transactions gave you a much more efficient distribution scheme. And even today, well, there's a nice one with rental cars, which is more recent. Imagine that car insurance for auto renters would cost less if people took more care when they drove. Let's just say they drove more slowly or more responsibly. The drivers would be willing to drive more slowly or more responsibly if they paid lower rental prices. But of course, without the monitoring, there's no way to ensure that contract is performed. Contract can't be made since speed isn't observed. But now, of course, it's quite easy to put a vehicular monitoring system in the rental car, and so you can then observe the performance and ideally end up with a better, more efficient arrangement all the way around. So those are just a few examples of how better monitors make for better contracts. The more things you can monitor on, the more efficient the contracts can be. Another thing you could do, which I think is interesting, is you can align incentives. So I wanted to talk about this online advertising. This kind of morphs into the monitoring contracts. If you think about web-based advertising, what happens is the publisher has space for an ad impression. You can stick an ad on the page. But the advertiser doesn't want impressions necessarily. The advertiser wants clicks and ultimately wants sales. So I don't so much care whether you see my ad or not, I care whether you buy from me. So how do you reconcile this? Well, this was Google's challenge back 7 years ago, and it was observing a simple formula. The value per impression that the advertiser places is the value per click times the clicks per impression. So what the publisher wants to do is get the ad on the page that has the highest value per impression, because that's what the publisher has to sell. And what the advertiser wants to buy is clicks or sales. So he cares about how much he's paying for clicks. So since you've got both pieces in this equation, you can charge the advertiser an impression, you can sell the impression to the highest bidder in terms of impression value, and the advertiser can pay for it in terms of click value. And what do you need to do? You need to estimate the clicks. You need to estimate how many clicks the ad will get. So imagine an ad, let's just give a little example. Suppose that you're selling 747s. You'd be willing to pay a lot for a new customer, right? But there aren't that many people who would really want to buy one. Maybe Larry and Sergey, but they've already got an airplane, right? So, it's not really worth very much in terms of how much the total impression value is, because it has such a low chance of being clicked. On the other hand, somebody's selling models of 747s that cost $10 or something like that. They're not really paid very much per click, but they could get a lot more clicks. So what happens, you have to look at the total value of that ad impression, not just how much you're willing to pay for a click, but how many clicks you're going to get. And of course, to reconcile those two incentives, the publisher side and the advertiser side, you've got to be able to estimate the click-through rate. And that's a huge statistical machine learning problem, and that's one of the things Google spends a lot of cycles on, is trying to estimate what the click-through rate, or more generally, what the quality of the ad is, so they can use that in ranking the ads and make sure that the publisher is getting the highest value ads. Aligns incentives between the publisher, the advertiser, and the user. And of course, when the ad is actually clicked on, you've got a revenue share between Google and the publisher, which is the same kind of revenue sharing that I was referring to in the video example. You've got to have a computer in the middle of all these transactions. It just doesn't work if you don't have that capability. But once you do have the computer there, then you can make advertising much more accountable, which is what I want to turn to next. All right, so the purchase could be linked back to the click or to impression, making advertising accountable, at least statistically speaking. And that means the advertisers and publishers can run experiments with different treatments to see what really works. So you can do this with search advertising, display advertising, mobile, TV, print, etc. You know, the old line of J.P. Wanamaker, the department store magnate. He said, half of my advertising budget is wasted. I just don't know which half. Well, once you can make advertising accountable, you can figure out which half is wasted and economize on that and advertise where your budget is actually effective. So this allows you to set up what you might call an assembly line for marketing, because the records of those transactions allow you to optimize the buying process from the ad to the sale. You can measure the advertising effectiveness, see which ads, which creatives, which treatments give you better performance. You can debug the purchase process. So when you're referring to Jeff Bezos, it was a great example. They looked carefully at the entire purchase process, found the parts where people were stalling, improved the flow, and we're able to get people to get to the transactions much more efficiently. And you can estimate useful marketing relationships. So that allows you to set up a kind of assembly line for marketing that you can fine-tune on a piece-by-piece basis. So just a couple examples. As you know, Google advertising model has people buying keywords. So you can buy keywords. Now, which do you suppose is more expensive? Diamond or diamonds? The singular or the plural? Which has a higher price? Well, the answer is diamonds have a higher price, because if your kid is writing a report on forms of carbon, he types in diamond, but if somebody's thinking to propose, they type in diamonds, right? So you've got this thing where the purchase generally is the plural, whereas the object itself tends to be more the singular, and it shows up in terms of how much advertisers are willing to bid on this. Oh yes, here's my little example of assembly lines. This example from Venice is really quite nice, because even though Henry Ford was supposed to have invented the assembly line, which I guess he did in a way, the Venetians had an assembly line much earlier. It's actually mentioned in Dante, because he was one of the few outsiders who was allowed to see the assembly line at the Arsenale. And since everybody in Venice could sail, they were all potential sailors. The only thing they needed to do was to make sure they had a way to create a fleet quickly. And if you could create a fleet quickly, then you didn't have to maintain a standing navy. You could use the ships for commerce, which is, of course, what all good Venetians were interested in. Oh yeah, so next point, data extraction and analysis. Once you've got this computer in the middle of the transaction, you can make these more efficient contracts. You can align incentives, so one side can be buying one thing and the other side selling the other. You can also study patterns. So the first example is the diamond and diamonds. Another example is how clicks vary over time of day. One of the problems we had in Mountain View for a long time is we measured time on the Mountain View standard. So when we looked at clicks by time of day, we only saw California time of day. And then eventually we built a system that allowed us to measure time on a local standard. And it was really quite phenomenal, because you could look at the rhythm of life. And even today, you could look at the click-through patterns and purchase patterns in different countries and see the siesta in Spain and see the Japanese working man working till 7 or 8 o'clock, and what time people start in the morning, and so on and so on. So you can pattern your advertising campaign according to the times that people are actually doing commercial searches. So you can build these predictive and causal models that, by extracting the data and looking at the patterns of behavior, you can build a model of what the behavior looks like and what's likely to be the most effective. But that isn't the end of the story, because you can also do controlled experimentation. Now, there's one of our Google employees in the research department. Once you have those computer-mediated transactions, you can look at the data, do the data mining, so everybody knows about that now, but you can do controlled experimentation to determine causality. And one of the reasons for Google's success is, in fact, this continuous experimentation and improvement. There's a nice book called Super Crunchers. I don't know if any of you read it, by Ian Ayres, who's an economist and lawyer at Yale. And he writes a lot about the different kinds of technology that people are using for data mining. But he has this one example, which I really love, of how he came up with the title of the book. So what he did is he created an AdWords account for each of the different book titles, and then found the one that had the highest click-through rate, because he figured that must be the best book title, and it turned out to be Super Crunchers. So this kind of ability to experiment should be available in every web environment, because you never know what actually is right. You want to create the environment and then tweak it, experiment with it, to try different variations to see what really improves performance. Because ultimately, when you look at these business decisions, it comes down to data versus hippo. And what's a hippo? That's a highly paid person's opinion. And the problem is that these highly paid person's opinion, well, maybe they deserve their pay or maybe they don't, but if they're highly paid, you don't want them sitting around debating, is the best background for an ad yellow or blue? because what they should be doing is saying, we'll run an experiment, we'll try yellow, we'll try blue, we'll see which one works best. And indeed, if you go look at Google queries, you can see what our answer turned out to be. So that kind of controlled experiment is hugely valuable. And again, it's one of the little pieces of our secret sauce is we built an environment where you could run literally hundreds of experiments at once. So people are always looking at the fact that, gee, I get different Google results today versus yesterday, or now versus an hour ago. Well, part of the reason is because that system is continuously evolving. There's hundreds of experiments that are going on at once, both on the ad side and on the search side, and the results of those experiments are then deployed into the algorithms that are used. Customization and personalization. Once you've got this computer-mediated transaction, the transactions can be optimized by individuals. So, of course, everybody's familiar with how this works on Amazon. Searches on Google have the same characteristic. And, of course, here, as in, especially in Europe, I should say, there's a lot of issues about when you do this kind of customization and personalization. There are obvious benefits for the users, I think. You get a better matching, a better way of finding the products and things that you're interested in. And I think hardly anyone quarrels with the intended use of data for this purpose, because it's for helping people find what they want when they're looking for search results and to find ads that are more relevant to the user's interests. But the question is not the intended uses, but the unintended uses. And so the challenge I think we face, us as a company, as a society, is trying to figure out how to get these benefits from the customization, personalization of all products and avoid negative consequences. So I'm not going to offer any views on how that could be done here, but I think it's important to understand that there are huge benefits from being able to do this kind of customization and personalization. But advertising is only the beginning. I've talked about advertising because that's what I work at Google. Sometimes I tell people I work at the dull side of the business, the side that makes all the money. The computer-mediated transactions not only make the advertising accountable, but they allow you to do all sorts of other optimization. As soon as you've got this computer between the buyer and seller, feedback, logistics, design and evolution, recommendations, and you can improve business processes across the board. So I want to talk a little bit about, go back to history and retell Paul David's story about the computer and the dynamo. Many of you, if you've read a lot in innovation, already know about this, but it's such a great story, it's worth retelling. Back in the 1800s, everything was powered with water wheels, essentially. And the way it worked is there was a water wheel and there was a shaft. Here's a nice picture, this is a model of the shaft that ran down the center of the factory, and then everybody's equipment had a belt that went up to the shaft, and then it powered that equipment. So it was a lathe or a saw or a drill or whatever. And of course, all the lathes were together, and the saws were together, and the drills were together because they shared the same parts and did some of the same operations. And the equipment, or whatever was being manufactured, was carried back and forth to one station to another. So you clustered these machineries by the type of machinery. And then along comes steam power, and, well, you just put the steam power on the shaft, and the steam engine ran the shaft, but nothing else much changed. Then along came electricity, and so what did you do is you put the big electric engine on the shaft, and everything else was the same. Now, over time, the electric motor got smaller and smaller, and for various reasons, they wanted to put the electric motor on the equipment itself, so the drills and the lathes and the saws and so on all had their own motor once this miniaturization process was completed. But they still cluster them together because that's the way you always do it, right? That's the way it's done. The way it's done is you put everything, all the drills together, and the work gets carried back and forth. So you had the possibility of the rearrangement of production, but no one took advantage of it because we've always done it this way. And it really wasn't until Henry Ford and the assembly line came along and broke the mold. And then, of course, you had this dramatic increase in the efficiency of production because you rearranged the flow of work. Now, my maybe bold assertion is, just as you could rearrange the flow of work in the factory, put the machines where they were needed, not where they were always been, nowadays we have the capability of rearranging knowledge work, right? And rearranging the flow of ideas through the organization. In the same way, 100 years ago, you could rearrange the flow of product through the factory floor. So assembly of mechanical parts, there was an efficient way to do it that was discovered once you had enough flexibility. So my claim is that when we look at the kind of knowledge work that people in this room do and people throughout the world, you can optimize the flow of ideas through the organization. So just as with this mechanical work, you can do the separation, distribution, and optimization of tasks. You look at every document that's created in the OECD or in the European community as a multi-authored document. Many, many people are working on it. Version control, tracking, sending around doc files. I mean, it's ridiculous. It's like moving the product from station to station prior to the assembly line. What you want to be able to do is you want to be able to have a single copy of the document sitting up there in the cloud. Everybody who has access to that document can modify it, shape it, develop it. You have complete version control and know who made each change at each time, and you get a far, far more efficient workflow than you do by using the old methods. So at Google, we have what we call the dog food initiative, and it comes from the line, you should eat your own dog food. You make dog food, you should make sure it tastes good. And so all of the products that we've turned out, Gmail, Calendar, Google Docs, we use them internally. And in fact, they become part of our workflow. And believe me, the workflow inside Google is far more efficient than these other ways of doing things because it's a way to use the technology to really optimize the task that's being done. Now we're still at the early stages of this. It's kind of like the assembly line in 1909, but I feel that the same technological innovations that were made then, or maybe analogous technological innovations, will push the production of knowledge work in the next decade or two. You can do the version tracking control, the experimentation and fine-tuning, and you don't have to do it in one place. So many of you somebody mentioned McKinsey earlier. So I was once sitting around with some McKinsey guys. I said, boy, you have such beautiful PowerPoint. How do you produce such beautiful PowerPoint? And finally, after 2 or 3 beers, they told me. It turns out that what they do is they throw together the same old lousy PowerPoint that all of us do, and then at the end of the evening, they send it off to India. And then they have a team of workers who spend the entire day, I mean our evening, their day, optimizing that PowerPoint, making it look beautiful. And then they send it back, and the next morning, McKinsey gets the PowerPoint, and then they go out and wow everybody with their presentations. That's how they can charge so much, because they've got these guys doing PowerPoint in India. I hope I don't. Are there any McKinsey people here? It's wonderful. I think it's a fantastic idea because you can outsource the details, essentially. Just like you improve the workflow on the assembly line, well, here's part of the end part of the process is somebody waxes the car, well, here they send it off to India and get it optimized. And it also allows for the creation of what you might call micro multinationals, and that's going to be the last thing I talk about in just a minute. How does all this wonderful stuff happening? Well, you've got cloud computing. Now, the trouble with cloud computing, I know Google's very big on cloud computing, but my feeling is only a CIO could love that term. Because most people would have to say, what's in it for me? Well, what's in it for you is the fact that it makes collaboration so much easier. You can access these documents from anywhere at any time with any group of individuals. And as soon as you explain that, then people say, oh yeah, that would be very nice. So what enables it is the technology of cloud computing, where there's this master copy that people can access, store once, read everywhere, access from any device by any time, and that facilitates both the teamwork necessary to create these multi-author documents and also to maintain and access them. So, not only that, the barriers to entry for online businesses are now falling very, very rapidly because any little business can go purchase space in a data center or storage on demand or a development environment from Google, from Amazon, from everybody else. So it used to be there was this scale barrier to entry. If you wanted to get into a web business, you had to have enough scale to manage your own data center. And then later, there were data centers that were managed by somebody else, and you would put your own computer rack in there and manage that. But now you don't have to do that. You can just go start your business and purchase the pieces of infrastructure that you need from the Googles, Amazons, IBMs, and other companies that can provide this. And that pushes the combinatorial innovation to a whole new level. Because it's not just the bits that are available, is the actual processing power is available. So anybody can start a business potentially, and you have lots and lots of people in parallel starting a business because of the easy availability of that infrastructure. So I was talking to some friends of mine, former graduate students at Berkeley actually. They said they had a business. And I said, really, where's your business? They said, well, I've got 2 people in Mountain View, I've got 4 people in New Delhi, I've got 1 person in Spain and another guy in the Czech Republic. So you had a micro multinational. And how did they communicate? Well, all those technologies I talked about earlier, the email, the web pages, the wikis, the voice over IP, the collaborative computing, cloud computing, those were the technologies that made the business run. Now, if you think about it, just a decade ago, a multinational, that's a big company that has this very expensive communications infrastructure, and they have to fly around on jet planes and do these complicated, expensive things. But now, a 4 or 5 person company can be a multinational company. It's just amazing. And in fact, in some ways, it's even easier because my friends, the entrepreneurs, they didn't mind staying up until 10 o'clock at night to correspond with their colleagues in New Delhi. And they didn't actually mind going to the Czech Republic because this was an old college chum of theirs they hadn't seen in a long time. So they would work with this technology, which in many ways was superior to what the largest multinationals could afford a few years ago, but they were also willing to let it go through its birth pangs in order to take advantage of this incredibly cheap communications technology that we have access today. And so that opens the doors to small businesses around the world. Multinationals can now be everywhere simply because communication and the computer mediation has become so incredibly cheap. So businesses can be born international. They don't have to necessarily start in one country and grow. They can be born international. They can have parallel innovation in technology and commerce. And I would say this is only the beginning because we're just at the early stages of development and deployment of this technology. So my vision is I think we'll see a huge burst in productivity, similar to the burst in productivity we saw with the assembly line and rearrangement of the flow of production, because we can now do knowledge work in a much more efficient way. Thank you. Thank you.